In our last couple of videos related to Revit, we had a lot of comments from audience wherein few are asking to upload the video in English, wherein other are asking for the explanation in Hindi. I would like to say that language is never a barrier and shouldn't refrain us or anyone else from learning. So this course, Revit BIM, will be delivered in both the languages, that is, whomsoever is comfortable with English, I'll teach them in English. और जो हिंदी में सीखना चाहता है, बेशक मैं उनको हिंदी में सिखाऊंगा. So now today's topic is BIM, wherein there is different interpretation about this terminology. That is, few think that it is a tool of Revit, other think that it is a component of Revit, wherein some think that it is a plugin of Revit. BIM is neither a tool nor a plugin nor a component of Revit. Building information modeling, as I said in my previous video, is a holistic process of managing data and information for a built asset, which today I'm going to actually show you by demonstrating a live example wherein I will model a 3D parametric door, and I will show that how building information modeling can be used. So guys, let's get started and welcome back to ptscadexpert. Myself, architect Kumar Kapadia from the city of Surat in Gujarat. This is a bunch of parametric openings including window and several different types of doors with various customized designs and various functionalities like editable dimensions, that is the editable height, width, swing angle, etc. I'll get back to this file later on, showing you all the different other functionalities of this 3D parametric elements. But for today's session, we are going to actually model this 3D parametric door, which has a door frame which is like stuck to the opening cut of the wall and running throughout the entire opening cut, and has an inscribed frame which is holding the solid door panel. But before that, I would like to take you to this project environment. And herein I'll click the architectural tab and click door. And I will host a single flush door onto this wall. I'll click 3D, change the visual styles to shaded. And now when I click this door, you see when I click edit type from the properties dialog box, I have this various different parameters connected to it, that is the thickness, height, the width, etc., which I can change. Also, when I click this door, you see I have an instance parameter, that is a swing angle, which I can change. That will rotate this swing. That is, I can completely open it and completely close it. But you see, when I change the swing angle, it doesn't really have any effect or a relation with this 3D element, and the 3D element stays in place. This is because this door family is built in using a different interface. That is, it is a system default template, door template, that comes with Revit. I'll just open the 3D of this. Again, change the visual styles to shaded. And now you see this door template, default door template that comes with Revit, is made up of two different components. That is, it has the 3D panel of extrusion, that is the 3D door. That is, when I select this element, it highlights this door that is made itself in this template family, and a 2D element, that is the door swing panel. The door swing panel is also an embedded and nested family, which is altogether made again in a different interface. So if I select this, I have an ability to edit family, and when I edit this, I will close out of this, and you see it by default open the 3D view of it. I will go to the floor plan, and you see this is a different working interface where we have all this 3D modeling commands, and these are the symbolic lines or the 2D symbolic lines that don't appear in the 3D but just appear in the plan view. Annotate symbolic lines, and from here you can use various different types of symbolic lines for the drafting purpose in plan. And this again has this two reference plane across which the symbolic lines are hosted. And if you'll see the 3D of it, you'll really see nothing but just these two lines. That is because symbolic lines only appears in plan and not the 3D. So you can see that this one door template is loaded or is embedded or is nested with couple of nested families. That is the 2D swing angle, the 3D extrusion which is made here itself, and then this is loaded to the project environment. So now we are going to model a 3D door template with its various components, that is the 3D door panel and the 2D swing, etc., which I'll show you from scratch. So I'll close all these files since we don't need it anymore. And here I'll click File, New, and Family, and it will open up this dialog box. And if you have all your libraries extracted properly, then you should be able to find this Autodesk Revit family door template. I'll open this, and you see this is a very similar environment which we just saw, the family door template, onto which we are going to host a 3D element and a 2D element, which again will be a different family files. So I'll just get rid of this and this 3D elements. I'll go to files, I'll open a new family again, and this time I'm going to open this generic model onto which we are going to design a 3D element. I'm just going to pull this out and I'm going to minimize it. So this is a bit little different work environment than what we just saw in the Revit door template, that it doesn't have any wall or any parameters or constraint, and the free range of movement where we can actually model the 3D elements. And from here, if I click create, then you have this different 3D modeling tools and this reference lines and reference planes. Before I actually start the 3D modeling, I would like to request the viewers to watch this video very carefully, and when you start modeling, perform the modeling in the same hierarchy and same steps as shown in the video, or else you will end up into various constraint errors. So a brief insight on what is reference line and reference plane. Reference planes in Revit are an infinite 2D planes onto which you can host an object. But for example, if I select this reference plane, then you see it doesn't have any endpoints or any finite length, and you can host an object to this reference plane, but you can just edit its x-axis and y-axis. It doesn't have an ability to edit its third dimension. That is, if we ever want to give a rotation to the 3D element that we model, then we need to host it to a reference lines. So this is the reference lines in Revit. If I click this and draw a reference line and see this in 3D, then when you hover over this, you can actually see, and when you press the tab, or I can say I can create and set plane and pick a plane, then it has this two work planes onto which we can model a 3D element. Also this one here. So the reference line itself has the reference plane onto which we can host an element and also give a 3D rotation to it. So let's quickly get started. So I will press create and a reference line. I'll snap to the intersection of these two reference planes and draw a reference line. Now when you hover over this reference line, you see it has two endpoints and it has a finite dimension. That is, when you hover over this, it says dimension, it says that make this temporary dimension permanent. So we can define the length of this reference line. Now what I'm going to do is I'm going to click this modify tool, that is align. I'm going to snap to this reference plane, that is center left right, and I'm going to hover until I find the endpoint of this reference line and click it, and I can see this little padlock that appears, and I'll lock it. I do the similar for this horizontal reference plane, that I will click align, select it, which says the reference plane center front back, and hover until I find the dot, click it, and again I'll lock it. So now this reference line is locked to this reference plane. Also, I'll give an angle to it, 45. So now we need to turn this permanent dimensions and angles into a parameters which we can edit. So here if you see the family types, it opens the family types and it has only this one parameter, that is default elevation. That is because this file is generic model. So we have to tell Revit that whatever we are modeling is a door, is a 3D door. So family categories and parameters, and from this list we are going to select door and say OK. So now when you click the family types, you see automatically it has loaded the several parameters basic that comes with a door, that is the height, the thickness, the width, etc. So now you can select this and change it into a parameter, that is width. For this angle, I'm going to click this create parameter, because the angle parameter is not loaded with the door default door parameters. So we have to create one new parameters. So this opens a parameters properties dialog box, and in this I'm going to add a family parameters, and we'll call it the 3D door panel swing angle, and I'm going to turn it into an instance parameter. Instance parameters are the parameters which you can edit instantly when you nest it into a different files, and the type parameters are the parameters which get only restricted particular that type. So this is the discipline common, the type of parameter, it automatically accepts an angle, since the dimension we have selected is an angle. So we'll group that parameter under, we have these different options where you can group it under, and I'm going to group it under constraints. Since it doesn't have any logic, but this is just the variety of different categories under which you can group the parameter, and whatever you find it relevant you can group it under, and I'm going to group this angle parameter under constraints. So it suddenly jumps to the other side. That's okay, not a problem. So now when you see, if I select this and if I change the angle to 90 degree, the reference line rotates. If I change it to 135, rotate again, back to 45. Also I can change this width to say 4 feet or something drastic like say 8 feet. So I will get back to 4 feet. I would like to create 2 more reference plane, that is the one in plan. I'm going to give it an align dimension and click, and also turn that into the width. Also I'm going to go to the front elevation, and here as well I'm going to define a reference plane, dimension it, and that should be equal to the height parameter. Let's change this to 7 feet. I'll come back to the plan, change the width to 3 feet and the angle of rotation to 0. Now if we ever want to model something in the elevation, if we want to edit the door panel in elevation, then we need to extrude it in elevation as well. And before we actually start the 3D modeling,
So I'm going to click create, and here set work plane, on which work plane we want to draw or edit. From here I will select this pick plane, and I will hover this reference line and click tab until I find this dotted line which shows the vertical reference plane of that reference line, and I'll click it, and it will say ask me to give an option to go to the front elevation. And now here I will click extrusion. I will select this rectangle. I will snap to this intersection of reference planes and draw all the way around. And you find this padlocks, which again I'm going to lock it. Locking is that I'm constraining this particular extrusion to this reference plane. And this time I'm going to say that the extrusion start should be 0 and extrusion end. You see this little button that is next to this this dimension, that is, we can associate a family parameter to it, and I'll click this and make this equal to thickness. Also, I will assign it a material category, which is again, it's not there in the door parameters which are loaded, so we need to create that one. And again, that parameter properties dialog box opens up, but this time the type of parameter which was angle earlier is now changed to material, since we have clicked this material and finishes button. And now I'll change this to the frame, the inscribe frame material, and I'll turn it to instance because material and angle parameters are something which we want every time different. What many instances we put for that particular 3D element, we want it to be different for each and every type, for each and every element that we put. I'll click OK. I'll click OK again, and I'll hit the checkbox. So now when you go to front elevation, you see that if extrusion which we made in elevation has extruded 1 feet from this center front back reference plane, because we have assigned it the thickness which is 1 feet. So I will go back to the family types, and here I'll change the thickness to 2.5 inches. That is the regular door panel thickness or the frame thickness that is holding the door panel. And click apply and OK. So now it has changed its thickness to 2.5 inches. But if I ever want this to be an inscribed frame, again I'll create the set plane, pick a plane, and I'll hover until I can find that vertical dotted reference line, and I'll click the front elevation, and I'll select this, and I'll say edit extrusion. And now I'll give an offset of say 1 inches. That is for the inscribed frame. I'll press TR enter, that is the trim extend corner, trim extend to corner command. The shortcut is TR enter, and I'll trim this edges. Before hitting the checkbox, I would also like to constrain this thickness and add it as a parameter. So whenever we expand the width or length, that dimension, that thickness or that frame width would always stay at 1 inches and in place. So I will select this, each of this dimension, and again I'll click this create parameter, and I'll call this frame width, and I'll keep it as a type parameter, and I'll group that parameter under dimensions. Okay, and now I will hit the checkbox. So now if we will 3 in 3D, I'll turn the visual styles to shaded. You see how you have this little piece of frame, the inscribed frame, which will be actually holding this door panel. So now we'll just test out whether everything works properly. That is, change the angle to 90, it's working. 135, 180, 270, the hardest angle. I'll change the width to say 4 feet and angle back to 45. Everything works perfectly. Back to 0. Keeping a check of parameters working perfectly is very essential when you model a 3D element. Just keeping a check whether you're not running up into constraint errors or anything. So now we are going to model a 3D door, but before that, this blue line pops up. That is because if you go to Manage tab and this Object Styles, the door family, when loaded, when we change the family category to door, then it has all the lines associated with this line width and this colors. So I'm just going to change and make all of them to black. And now you see your inscribed frame has changed its color to black. So now we are going to actually create a 3D door panel within this inscribed frame. Before that, I would like to create some parameters. So I'll go to this family category and parameters. I'll go to this family types and add a parameter which says the door panel thickness. And I'll keep it as a type parameter and I'll assign it a value of 1.5 inches. I'm going to make 2 more parameters saying this, the door panel, I'll write DP for short, exterior, and one more parameter, door panel interior. And now I'm not going to assign this parameters to any dimension, but I'm going to turn it into a formula that this 2 parameters are actually going to use this thickness and this door panel thickness. And that is, the door panel exterior should be the thickness of the inscribed frame minus the door panel thickness, all of that in a parentheses. And that should be divided by 2. And the door panel interior would be the door panel exterior plus the door panel thickness itself. Door panel thickness, yeah, that is a 2 inches. So I'll explain how that will get to use. So I'll create an set plane and pick a plane, and I'll hover until I find that vertical dashed reference line, and I'll click the front elevation. And now I'm going to create the extrusion, and I'm going to create a rectangle. And this again, I'm going to lock it. And this time I'm going to say that the extrusion start should be the frame, the door panel exterior. That will turn it into a 1/2 inches. And the extrusion end should be the door panel interior. That is the 2 inches. And hit the checkbox and go to the plan. And now you see that this is actually the use of turning those parameters into formula, that whatever is the thickness of this inscribed frame, this door panel would always remain in the center. For example, if I change this thickness to 4 inches, or maybe say something drastic like 6 inches, and say apply, you see that the inscribed frame has expanded, but the door panel is still in the center. And that is because this door panel exterior and interior is driven by the thickness parameter and the door panel thickness, which we have already mentioned, and turning it into the formula are governing or regulating that particular thickness of the door panel and always keeping it in the center. I will again change the thickness to 2.5 inches and apply and OK. And now let's test everything. Turn it to 45. Yes, it works. To something 4 feet. Let's also check in height. Something drastic like 9 feet. And let's view this in 3D. And let's change the angle to 180. Apply. Yes, it rotates. Let's go to plan. And let us completely shut it down. Change to 0. Apply. And width back to 3 feet. So this becomes the 30 by 70 door. I change the height to 7 feet. Apply and OK. So now this is a 3D parametric door, which we can actually nest it to the door template that comes with Revit. But before that, I don't want to lose anything, so I will just make a save as of this. Save family. I'll go to desktop. I'll make a new folder saying it ptsbim, and I will call this family as door panel 3D adjustable swing, and save it. One step I forgot is to assign this door panel the material. So again, I'll hit this button and turn it into a parameter wherein I'll say this to be the door panel material. And again, I'll make it an instant parameter, and since it is material parameter, it has already grouped under material and finishes. OK, and I will just press OK. And now we have this 3D door. Let's start modeling the 2D component of this door. And I'm going to select all of this and press the filter button, and I will get rid of the dimensions. I'll uncheck the reference line because I want it in place, and also the dimensions. And I'm going to select rest all and delete. I'm going to change this 3D swing angle to 45. And now we are going to model 2D element in this file itself. So I'll go to the family types, edit this, and edit parameter, and I'll change this to 2D door panel swing angle and keep it as an instance and group it in the constraint as well. Apply and OK. Rest, I'll keep it all as it is. I'll just select this width and lock it. Now when you want to model a 2D element which doesn't have any extrusion or have a third dimension, and we just want it in plan view, then you need to create a set plane, pick a plane, and this time we are going to really select this, annotate, and in that symbolic lines, and which says that it is not a part of actual geometry of the component or building model, and click this. and this has the various subcategories defined, but for now I'm just going to keep it under door projection, and I'll click this pick lines, and this time I'm going to select this and lock it. Almost I'm going to follow the same step, but there is a difference. I'll show you what. And this time I'll click 2.5 inches and offset it 2.5 inches from the line just we made. And now I'm going to align dimension and select this line, and you see here what I select should be highlighted here. So if I hover over the mouse over this line, it says the symbolic line, the reference, but I'll press tab until it says the reference line, and I will dimension it from the reference line to this exterior line, drag it all the way around up. I don't want to see this extension going, so I'll just click this dimension, going to edit type, and click this fixed dimension line, apply and OK. And again I'll press align dimensions, tab reference line, and change that into the thickness. And I'll close this shape, again annotate symbolic lines, and this time I'm going to draw a line which this little dotted line pops up showing that it is perpendicular to this line. I'm going to draw another line which is exactly 90 degrees to that line. I'll press TR enter, that is the trim extends, and I'll close this shape. And now let's test out whether if I change this thickness to 4 inches, that should expand, and it is. Now I'm going to strike an align dimension, an angular dimension to the perpendicular point, so that it doesn't loses its connection when we edit the width. So this 90 degree, I will lock it. This 90, I'll lock it again. And this line, 90, I'll lock. You don't really need to give angular dimension to these two lines, but even if you do so, it will not accept. It will say locking this dimension would over constrain the sketch. So I'll get rid of that. And now with this, I will again click annotate the symbolic lines, and this time I'm going to draw a center end arc for the door panel swing. So I'll click this endpoints of the symbolic line, click on this end, click on the intersection of the reference plane, and click it all the way around up. I'm not going to lock anything. When I select this arc, the center end arc, then here in the left pane you have this center mark visible. I'll just check that box. What that does is it makes the center, I'll just turn on this thin lines, so you can see the center of that arc is visible now. And now I'll click align, I'll click this reference plane, select that point and lock it. The same I'll do for this horizontal reference plane front back. Again select this center point and lock it. Next, what I'm going to do is I'm going to highlight this temporary dimension and make it permanent by clicking this point, and I'm going to make this equal to the width. Also, I'm going to click this arc, and we have this angular dimension temporary popping up. I'll turn it into a permanent dimension, and I'll change it into a 2D swing angle. Oops, 2D swing angle. Yeah. So now we are going to test out whether it works or not. So let me change the angle to 90 degree. It rotates 135 and 180, and don't forget 270, the hardest angle. And coming to 270, I'll change the width back to 4 feet, and then again this 2D swing angle to 45. And seems like everything is works and we don't have any constraint errors. I'll change back the width to 3 feet since it is a 3070 door. Now what I'll do is I need to add the inscribed frame thickness and the door panel itself. So I'll select all of this. I'll go to filter, and I want the lines and the reference lines to stay in place. I'll just select the dimensions and press it, or there's just see this eyeglasses. I'll click on this and say hide element. Now you can properly visualize it, and this arc center radius, the center mark, I don't need to see it anymore. So I'll uncheck it. Sorry. Now just turn this off. I'm going to click offset, and I'm going to offset 1 inches from both of these corners. And I'm going to dimension it. And if you remember your 3D element, then you know that this should be an equal to the frame width which we defined. So if I click this and if I change this to 4 inches, you see how it expands. Change it back to 1. I'll make a door panel saying offset of 1 inches. Again, an offset of say 0.5 inches. The dimension doesn't matter because we anyway going to assign it a parameter. I'll click this align dimension, and I'm going to click the exterior most part of this symbolic lines to the line we just drew, and going to make it a dimension. The same I'm going to do it for the inner line, and I'm going to make it the dimension as well. I'm going to call this the door panel exterior, and this to be the door panel interior. So you see that this door panel always remains in the center irrespective of the thickness. And if I change the thickness to say 6 inches, that door panels always remains to 1.5 because we did all that math for the 3D part, for the 3D component, and we have defined already all the dimensions. So now changes this back to 2.5 inches. I want to clear it up a bit, so I will click this trim extend multiples. I'll select this and I'll trim it. Again, trim extend, I'll select this and I'll trim it. Now I just again need to turn on the dimensions, and you see it is a big mess, but you can't help it. Turn this to 90. Yes, it works, and rotate. Change the width to 4 feet. Don't forget the hardest angle, that is 270. Everything works fine. You can see the swing angle all the way around and back to 45. And the width, I'll change to 3 feet. I'm going to do a save as of this family, calling this door panel 2D adjustable swing. save. Now we are going to merge all these parts and pieces onto that door template file. We are going to bring that family and nest it into this family since we want to make a door. So I'll go to family files, and open this door panel 3D adjustable swing. And load that into the project. Family 9. We haven't saved it. So let's quickly save it before we lose something. I'm going to call this door 2D 3D solid adjustable swing. Solid because it has a solid door panel. It doesn't have any extrusion within. And when you bring it into this family, when you click it, you see it has an instance parameter which we assigned. Also had this inscribed frame material and the various type parameters which we need to pass on to this family. So I will click this and make it equal to width. The thickness should be equal to thickness. The height should be equal to height. I'll click OK and apply. And this has an angle parameter which I'm going to associate. You see this, you can press the button and I'm going to again click this and make it 3D door panel swing angle. I'm going to make it an instant parameter and group it under constraints. And the inscribed frame material to same inscribed frame material. Make it instance as well. Why did the door panel material then pop up? Okay, I forgot to assign this door panel material. Door panel material and instance. Okay. And then load back into the project where it says the door 2D 3D solid adjustable swing and overwrite. And now you see it has this door panel material which we can also associate to the door panel material and turn it into an instance. So now we are going to pass on this 2D swing angle into the project environment. But before that, I'll go to this family types. And since we made it into the 3D component, it has few parameters which are not needed for this 2D element. So I'll get rid of it with 3D swing angle and the material parameters, which actually has nothing to do with the 2D component. The height. So height is the built-in parameter, so you cannot actually delete it, but I'll change it to 0. And what we need is this width, thickness, the door panel exterior, interior, and the door panel thickness. I'll click apply OK and quickly load it into the door 2D 3D solid adjustable swing. And let's quickly pass on the parameters and associate the family parameter, that is 2D door panel swing, an instance parameter, and group it under constraints. And we don't need to worry about the material because we have already deleted the material parameters which were part of this 2D family, but we need to pass on this thickness to the thickness in this family, and the width should be equal to width in this family. Apply and OK. So now I will just close this two family files since we don't need it. And now we want to get this 2D component and 3D component in place. But before that, we need actually a profile which needs to be hosted to this wall, which would sweep out around the entire opening cut of this door. So quickly let's make that. So I will open a new family, and this time I'm just going to open the file which says profile. So now this is again a different work environment, which is neither similar to the door template that comes with Revit, neither to the generic model, but is a different interface where we don't have the 3D drafting commands. And this is because a profile is a 2D element which we need to host to an element which would sweep out along the entire sketch path. So let's quickly design a wooden profile for a door frame. So I will say create, and I'll click this reference plane, and I'll draw one on the top and a couple of reference planes. And onto the left, the few reference planes. Now I'm going to say create, and this time I'll pick the lines, and I'll pick lines, and I'll select all of this and lock. I'll select each of the horizontal, sorry. Make sure that when you select, you don't forget to lock these lines to the reference planes. Now I need to do a little bit of trimming and clearing out the sketch. So I will do that quickly, and we'll make this, and this should be equal to, I will say split element, and I will join this. Also I will again split element, and I join this. Just make sure that all the lines should, since we splitted the lines and we made a trim extend and we edited it, that might have lose the connection with the reference plane. So we just need to click this align and check that all of these lines are locked or not. So we see this lines is locked, but this has lost its connection. I will lock that. I will see this is locked. This is locked, but this has lost its connection. And that is how I'll again lock each of the lines to the reference planes. Yeah. So I need to add in a couple of parameters here. So we'll start with that. One I will call wall thickness. Add a new parameter saying rabbit width, rabbit depth. These all are the elements of a wooden frame: the rabbit, the throat, depth, the door panel thickness, and I'll click apply OK. And now I'll start dimensioning this, and one more parameter I need to add is the frame width. So now I'll start dimensioning this reference lines. We'll call this to be equal to frame width. Make sure that you select the reference lines and not the actual symbolic lines. And this should be equal to the rabbit width. Should be equal to rabbit depth. This should be equal to the throat depth. The same for this. This throat depth. And least but not last, the wall thickness itself. Yeah, one more. This to this. And let's call it the door panel thickness. I'll make it a little bit scaled down so we can properly visualize the parameters. Oh, okay. You need to assign one more parameter to this. That is, this is going to be the throat width. And now let's quickly change the numbers. The door panel thickness should be equal to the thickness of the frame in the host file. The frame width should be equal to 2 inches. Rabbit depth should be equal to 3 inches. Rabbit width should be equal to 0.75 inches. The throat depth should be equal to 0.5 inches. And the throat width should be equal to 1 inches. And the wall thickness should be equal to 6 inches. That is the wall thickness in that file. And now you see this very much looks like a door frame, a wooden door frame that can be hosted. So I'll quickly load this into the project environment. And you see it really nothing pops up. That is because we have to host it to the profile of this door panel cut. So I will go to the exterior. I will remove this equal sign, which is like this. This is the standard symbol showing that here it is the door swing, and this is the hinge part, which we don't really need it. You need to create a couple of reference planes here and one here. And I'll strictly dimension those since we need to give it a parameter, and I'll select all of this and say this should be equal to the rough opening gap. I will scale down and I'll change the rough opening gap to say 1 inches. And now you just make sure that you are seeing the lower left corner of this window. And when I select this door, and when I press tab until I find this opening cut, and I edit sketch, and I'm going to offset it all the way 1 inches to the either sides. And I'm going to select this original lines, which were the lines of the door cut, and I'm going to delete it. And then I'm going to press align, and going to select this reference plane we just made and align and lock. The same for this top one, and the same for this side as well. You need to join this by pressing TR, trim extend corner, and when you do this it will join the edges. And now you just need to click finish edit mode, and you see now we have made the opening cut 1 inch larger. Just we want the frame to fit within this area. So I will create and this time I'll select this sweep, and it gives two options, that is sketch path and pick a path. So I will select this sketch path and I'll say pick lines, and I'll select this outer reference plane, inner reference plane just we edited, and I'll lock. I press align. Oh no, sorry. I'll pick this another reference plane, lock it as well, and this. Now we just need to clear it up a bit. So again, this TR trim extends, and for the lower line I'm going to click align, and I'm going to select this reference level and align the endpoints of this lines and lock it to the reference level, and hit the checkbox finish. So now it says ask me to select a profile. So when you click select profile and you drop down, you have this profile which you just loaded. It doesn't have a name. So let's quickly name it. Going to the profile, I will say rename. Since we are in the sketch mode, it doesn't have an ability to rename, but we'll select this and just finish the mode, and we'll just click this and rename this, saying this wooden frame, and rename this as well to wooden frame. And now we need to see this in plan. So this entire profile has been hosted to this wall, but it is not like hugging the wall. It's not like stuck to the wall. So I'll close this because we don't need it anymore. I'll go to the reference plan and floor plan, and when I select this element, and if you come down, then you have this options saying profile is the wooden frame, the horizontal profile, the vertical profile, and the angle. So now we need to play around with this parameters to get it in place. So for the horizontal profile, I'll say I want it to be 2 inches. So it went 2 inches apart. Angle, this is just trial and error, playing around with how to make it in place, how to get it in place. So now this profile itself has some parameters which we need to pass on to this family. That is, the door panel thickness should be equal to the thickness, the throat wall thickness should be unequal to, it doesn't have parameters, so we need to make one, that is the wall thickness. And one more thing, the frame width should be equal to jam frame width, and the throat depth should be equal to the throat depth. We really don't need to assign this other parameters, and we'll just keep it like that. So now we need to give this wall a parameter saying this should be equal to the wall thickness, and by going to the family types I will go to that wall thickness and edit that parameter and make it an instance and a reporting parameter. This is because I want this door to be part of any wall irrespective of any thickness it has in the project environment. This frame should and this door should stuck to it. So we'll change this to the reporting parameter. The reason behind making this wall thickness a reporting parameter is I wanted to report back to the uh, project environment that whatsoever is the dimension or the thickness of that wall in that project environment, this wall will adapt to that and will report back to that and will change its thickness to that. I'll show you that. But before that, let's get that in place. Now, if you select this and change the vertical profile offset to say how much inches, 3.5 inches. Now we can actually turn this horizontal profile and vertical profile offset into a parameter to make this happen in place, because when we design this profile, you clearly know that we have made this a parameter, that is the wall thickness, and this is the throat depth. So we can make this a parameter, that is this should be equal to the jam frame width, and this should be equal to the vertical profile offset. Yeah. And now I'm going to the family types, and I will say that the vertical profile offset, since we are going to use this wall thickness, which is the reporting parameter, onto this vertical profile offset as a formula which we're going to use, we need to turn this vertical profile offset into an instance parameter, and we'll type wall thickness minus divided by actually the wall thickness plus throat depth times 2, because the throat is on the two sides, and all of that in parentheses and divided by 2. So that will make this vertical frame offset 3.5 inches, and that will place it in place. And now when you see this in 3D, then you have this profile, the door profile, which is like going through the actual opening cut of the wall. And now we are going to add each of this 2D and 3D element to this place, wherein you know that we have modeled this, assigned this at the 2.5 inches when we drafted this profile, and given it a parameter of the door panel thickness, since we know that we want a 2.5 door panel to fit into this frame. So first I will I'll change the 3D swing angle to 45, apply and OK. And now I will press this align button, click this reference plane and find until you get this this line which you can snap to and lock it. And I'll align the outer edge of this frame and find the horizontal line. This actually are the reference planes in the parent file onto which you hosted this 3D element which you are snapping to. So snap this horizontal and lock it. So now you see let's test out certain things, that if I change the 3D swing angle to 0, it should close, and if I change it to 180, it should completely open. Let's change it to 135 for now. Also, the width and height parameter, the width, if I change back to 4 feet and apply, then this door will expand. And of course the height parameter will also work, but for that we need to go in 3D, which we'll do it later. Right now I'll change this to 3 feet, click apply, and now we are going to align this 2D element. So make sure that you select this reference plane, and this again has this line which we can snap to, that is basically the reference line for the parent family, and lock it, and the exterior edge of this frame and the horizontals, lock it back. And now when you go to 3D and so WT, you can test out the height as well. That is, if I change the height to say 8 feet, apply, that expands, and back to 7 feet. Just we need is to test out the 2D element. So when I change the width to 4 feet and the 2D swing angle to say 90 and apply, so you see, so this is basically the this is basically the representation of the 2D swing angle, that it goes around with the frame, which is not there in 3D. So if I'll click this, I'll change the 2D swing angle to 180, apply, it will completely open, and 0, and apply. It will show an error, but that's okay. You just need to click OK, and that closes, and back to 45. Okay, so now we are ready to host this door family onto the project environment, and I'll click file and say new project, and I will select, I'll open this template files and go to English Imperial and select system default template, architectural template, and click open, and I'll draw a wall onto it. So now let's go to this door template, wherein we have the 2D element and the 3D element and a 3D frame which is modeled onto this door template. But before hosting it into the project environment, I would like to select this door panel 3D element and change its visibility settings and uncheck the plan / RCP, that is the reflected ceiling plan. I will click OK and load that into the project. And now let's host this door onto this wall. So now let me quickly drag this out and minimize this. Let me turn on the 3D view of this. Let me change this to shaded. And you see, when you click this door, you have an ability to edit the 2D swing angle, that is 290, 135, 180, and back to 0. And similarly, you can also edit the 3D swing angle. Say I can completely open the door and I can close it. Also, I can change the associated width and height, which you can see that if I change this width to something drastic like 6 feet or 8 feet, maybe say 10 feet, and click apply, how this door expands. Also, we have hosted this frame to a wall in the door template, wherein we have made a parameter wall thickness, which is the reporting parameter. That is, it report back to the figures in the project file. That is, if I change this generic wall and edit type and change its thickness to something drastic like say 18 inches and click OK, apply. So this frame also expands. So this is a complete 3D parametric door. Now I can select this door and edit type and duplicate it, saying door 2D 3D solid adjustable swing 2, wherein I can define a different height and different width and say OK. And I can place the original door having the 30 by 70 dimension to this. So this two now are the different door, the same doors, but different dimensions, that is different type. You can actually define this type here, or if not this, you can also define this type in the door template file by going to the family types and saying this is a new type. This is the type A, which is the 30 by 70 door, and I will define a new type, that is type B, which is something like 10 foot by 4 feet 6 inches. Apply and OK. So now we have the two types defined here itself. So now that you load it into the project, overwrite existing version, you have the two different types for the same door, that is type A and type B. But this you change this to type B and it will automatically expand. Now this is the solid door panel. What if we want this door panel to have a piece of glass within it, and that should be part of this family as well? So we can do that as well. I'll show you how. I'll select this door panel 3D adjustable swing, go to edit family. I'll drag this project file, and for now I'll minimize it. Go to the reference level and set plane and pick a plane, and I'll tab until I find this vertical reference plane, wherein you can select the front elevation. And now we'll turn this solid adjustable door into a different door type, that is the style and the rail. Style is generally the vertical members that a door has, and a rail is the horizontal members. So let's quickly do that. So I select this extrusion, edit extrusion, and I will draw two lines on this either sides and two horizontals, and I'll quickly trim, extend and clean it up. And now I'll strike a dimension from this side and turn it into a parameter which I'll call style width. And this I will say to be the rail bottom height, and this to be the rail top height. I'll go to family types and change the rail bottom height to be 3 inches, and similarly the rail top height also to be 3 inches. I'll click apply and OK. And also the style width to be 3 inches. Apply and OK. And I'll hit the checkbox. So now if you see in 3D, this inscribed frame has the door panel frame, which again has a cut. And that cut is to take the piece of glass in it. So I'll go to front elevation, and before that I will define a few parameters, that is the glass thickness. We are going to do the same computation and the same mathematical formula we are going to lay for this glass piece to stay in place, just as we did for the door panel, the solid wooden door panel. I'm going to strike 2 more parameters, that is the glass offset exterior and the glass offset interior. And the glass thickness should be the 0.5 inches. I'm not going to use any of these parameters. I'm not going to assign any of these parameters to the dimension in the file, but I'm actually going to use it for creating the computational formulas. I'm going to make this glass offset exterior equal to door panel exterior plus the glass thickness. So that will make this extrusion half inches away from the door panel exterior. Whatever is the door panel exterior line, this extrusion will start adding half inches to that. And the glass offset interior should be the glass offset exterior plus the glass thickness itself. Yeah, so that is a half inch. So apply and OK. And now I'm going to create an extrusion, and I'm going to draw these lines and lock it. And this time I'm going to say that the extrusion start should be the glass offset exterior, that is 1 inches, that is the glass frame, the door panel exterior plus half inches. We made the formula, and the extrusion end should be the glass offset interior. And I will assign this a material, saying it to be the glass thickness, and I'll make it an instance parameter. Glass thickness is already defined. Oh, sorry. Glass material, an instance parameter, and hit the checkbox. And now going to this family types, I'll make this glass material equal to the glass in the material browser default asset. It has the glass material already defined, so that will turn it blue. And now if you watch this in 3D, so now you have an inscribed frame with a door panel and that door panel is holding the piece of glass, and everything is in center. That is because we have computed it with several formulas. And ever since, if I change the thickness again to say something drastic like 6 inches and click apply, you see this door panel frame and the glass always remain in the center. So let's again test out few things. That is, let's go to the 3D and let's change the 3D panel swing angle to 45. Yeah, it rotates 90. Okay, and back to 45. So everything works correctly. But now I need to save this file as a different file, since we have opened that door panel 3D adjustable swing and we were doing all the modifications in that file itself. So we need to change this file and do a save as family. And this time I'm going to call this the door panel 3D uh, door panel 3D style and rail door. Style and rail adjustable swing. Yeah, that's fine. Okay, but now we also need to make this same changes in the 2D component. So I will load this into the project, that is the door 2D 3D solid adjustable swing. And it's placed here. Let's keep it here for now, and let's edit this 2D adjustable swing component, and I will close all this. Yeah, and we'll select this 2D component and edit family. So in this it is already a mess but anyways we have to do. So I'll select once again all of this, and I'll click filter, and we uncheck the lines, the reference line and the reference plane, and only select the dimensions, and click this eyeglasses and hide element until you can see only the door frame and not the dimensions. So now we need to add uh, a, a style member to this door panel and a piece of glass, but this time we are going to add everything to this 2D element. So let's start. I will offset and I'll say this to be 3 inches, which is the style width, and here as well I will trim extends. Oh, sorry. And I will dimension this to be the style width. And now I want a piece of glass in it, and we already have this the door panel thickness 1.5 inches, and we want to position the glass in between this door panel thickness. So again we need to make the computational formulas. So let's start. We need to add in some parameters, wherein I need the glass thickness, that is going to be 0.5 inches, the glass offset exterior, and the glass offset interior. So now this glass offset exterior would be the door panel exterior plus the glass thickness like we did in the 3D part, and the glass offset interior would be the glass offset exterior plus the glass thickness. Yeah, apply and OK. And now we're going to offset a couple of lines, half inches from this and half inches from this. So I'm going to strike a dimension from this outer line up to this, and I'm going to call this to be the glass offset exterior, and this to be the glass offset interior. And I'm just going to properly edit this sketch. And now if I change this thickness back to 5 inches, you see that everything remains in place. That is because we have added the computational formulas that ways. So 2.5 inches. And again, I need to do a save as of this family as well. Family, the door panel, 2D adjustable swing, but I will add door panel 2D style and rail adjustable swing. And I load that back into this door 2D 3D solid adjustable swing project. And now I'll close this. Now, what if we ever want this door to have a different type, wherein this door panel solid adjustable swing will change to the style and rail. So how can we do that? So that is going to the family types, and Revit has an ability to define a parameter which defines its type. That is, if I select name this parameter door panel family, then the type of parameter I'll make it to the family type. And in that family types, you have several different categories wherein you have to look for doors and select OK, and automatically it will be grouped under others. Okay, that's fine. And now when you drop down, it will enlist all the types of different doors, since this 2D 3D style and rail 2D and 3D, all of these families are made as the family type, the family category door. It will show up under this family door panel family, wherein we can change its type as required. For example, I will delete this both, since we have it here in the project browser. We can load it anytime. So for the type A, I want this to be the solid 3D adjustable swing. I need to define one more parameter for the 2D component, that is the door panel family 2D, and I'll also make it a family type, and I'll say this to be a door, and I'll also group it under others. And here I'm going to select door panel 2D adjustable swing. So this type A has two door panel families. One is the 3D adjustable swing and the 2D adjustable swing. I click apply, and I will define the type B, wherein this 3D adjustable swing will change to style and rail, and this 2D will change to 2D style and rail adjustable swing. I'll click apply and OK. And now I need to add this to the door panel 3D style and rail swing, and this 2D element to the door panel family 2D. So again, we need to adjust the height and width with respect to this type. So I will click edit type. I will edit the width to the width parameter, the thickness to say thickness, and the height. Okay, this is a 2D element, so you don't have height. And the 3D to edit types, the width to width, thickness to thickness, and the height to height. Apply and OK. And you see, this one family has two different door types. That is, if I change this to type A, this will reduce its size, and the door family type will be the solid adjustable swing. And if I change this to type B, this will expand and change its type to style and rail door. So now we are going to open up that project environment. So now I'll change this type back to type A. And now we are actually going to load this door into the project environment. But before that, to avoid any conflicts, let's delete this door, and I'll delete it from here as well. And I'm simply going to load this door onto this project. And this is the type A. And again, I'll click the door, and this time I'll select the type B. And can you see the change in the swing angle, the 2D swings? This is the solid adjustable, and this is the style and rail. Let's click the 3D of this. Then one door has two different types, wherein we have this instance parameter which we can change to properly visualize this. Yeah, that's it. And now finally getting back to this file where you have various door types loaded with various customization and designs, and I will show you the various functionalities of this parametric doors. And if I select this door and change its type to type B, then you see how the door enlarges and its type is changed. I can change it to type C, and its type is changed, and now it has been converted into the decorative door panel. Similarly, this is the double door swing, double adjustable swing, and if I change this to type B, then you see that initially this was both the shutters were equal, having equal distribution of width, but now when I change this to other type, it changes. It becomes an asymmetrical door. That is because in its family type, I have given it a parameter saying symmetrical frame offset, which defines whether I want this door to be symmetrical or asymmetrical. The same follows for this. This is a single panel door with a side light and a transom on it. I can again change its type to type B, and you see how it becomes asymmetrical. And if I change this and change its type to type C, then it becomes a decorative door panel with side light and transom. Now this is a double door with one swing as a side and rail and another swing with the louvers. So let me open it up to have the clear vision of it. Angle of rotation 90. And you see this panel is having a bunch of louvers, and adjustable louvers which can be opened and closed. And again, if I change the angle of rotation to 0, this is the door. Also, I can change it to type B. And you see this becomes the door frame, the door panel with the vertical louvers. If I close this, and if I edit this and turn off the symmetrical frame offset, apply, that will make both the shutters unequal. Now this doors is having one panel with one shutter which is hinged at the side, but the other shutter is a centrally pivoted door. Let me show you. So you see it rotates from the center. Again, I can go to edit type and change its height to something drastic like 9 feet, and the transom height to something like 30 inches. Apply and OK. So see how the transom expands. So this was a centrally pivoted door. If you ever want an off-center pivot, then that is also possible. So you see this shutter rotates from an off-center, and again we can change its type to say type D, and you see how it's, and this is an asymmetrical division wherein the one swing is having a larger width and this shutter is having the smaller width. Let's open up this door. Yeah. Now coming to this door. This is the sliding folding doors with 1, 2, 3, 4, 5, 6 shutters, and if I open it, then you see it opens. You can also change the angle of rotation, and this is a centrally pivoted shutter with horizontal louvers. I can obviously change all the louvers angle for all of the shutter, but that is not important. Important is this division, that even if I change this to type B, that will become a bifold door with only 2 shutters. And also the width and height has been expanded. So this is the window. Same way, the parametric window, wherein I can open this up and can edit type and equality dimension to say 3 foot. Now, let's keep it 2 feet 6 inches, and let's change the overall height to 12 feet. And the casement window height, I'll change the width to say something like 10 feet and the transom height to say 3 feet. And I will turn on this symmetrical frame offset. No, I'll keep it unchecked. Okay. Apply. Okay. And see how the window expands. Also, it has an instance parameter wherein I can add a sunshade extension to it. If I ever want this window to have a symmetrical division, and I just need to turn on this symmetrical frame offset, apply, and it will divide the window equally. And basement window height to say 4 feet 6 inches, and that would make it visually appear almost equal. Yeah. The same follows for the curtain walls, that has embedded family of horizontal and vertical louvers which can adapt to any height and dimension, that is its width and height can be changed. So all this was about the modeling part, the design part. Now what about the construction part, and what if you ever want to make the working drawings of it or the construction drawings of it for the execution on site? So that can also be easily made in Revit. So I'll show you that. So I'll go to the floor plan, and from here you can make a call out of any portion of the window or door, and then make it a different file and change the category, and you can dimension it, add details, draft whatever you want. Similarly, the same thing follows for the window in section, that you can make a call out of this, and all the drafting details, the 2D details that you want to add, you can just add by turning on the category and adding the 2D features to this. If not this, you can also add a legend, a door legend, showing the plan and the elevation view of this. Also, there is this drafting view in Revit, which allows you to draft all the details, all the 2D details of the plan section, the enlarged details. But drafting in Revit is a bit tedious job, since we as an architects or designers are working on AutoCAD since over years, and we have a lot of detail established there. This detail is actually not of this door, but this is just to show you that you can import an AutoCAD drawing into this, and you can also edit that. That is imported categories. There is the drawing, door, window, and it has the various layers. If I'll just select this one layer, you can constrain your layers, and then you can come here and you can select the line type of that particular layer, add a color to it, add the line weight to it, and each and everything, whatever modifications you want, you can do to it. And then after doing this, finally, one more thing. Whenever you model or design something in Revit and properly feeds and constrain it, it automatically allows you to generate a schedule associated to it, which in AutoCAD we have to do it manually. So you see we have a lot of labor work is avoided, and this schedule shows that the door D1 type has 2 counts, that is the 2 doors of the same category is been added to the floor plan of this. And finally, it allows you to compose a sheet wherein you can add all the details associated to this particular openings.
So this was all about building information modeling, wherein we feed data and information for a physical asset of the building, in this case a door, which helps us minimizing the confusions and mismanagement during execution on site. And once model, this 3D models can be used again and again with few alterations, irrespective of the project and dimensions, which actually can be edited. So guys, the clock is ticking. It's time for the class. If you haven't yet enrolled for the course, quickly sign up and let's meet on one-on-one for this course Revit BIM, wherein I will teach you Revit from scratch. But the basic focus and intents of the course will be on 3D parametric modeling, adaptive components, curtain panel pattern base, and yes, of course, the visual scripting language, that is Dynamo. So let's learn together and let's grow together.